Tim Roberts, Application Engineer with Go Engineer. This quick tip video on flow simulation, I am going to give you my 5 recommendations I think everybody should do before hitting run on flow simulation. Okay, first thing I recommend, go to File, find References. Understand where your files are. We really don't want to be running large flow projects over the network, even small projects. If all your files are local, by default all your results will be written local, and the results for flow simulation can be extremely large. This is nonlinear analysis. Okay, second thing I recommend is you just do a quick tools check in SOLIDWORKS. This is a SOLIDWORKS tool. Looking for specifically invalid faces or edges, or general faults would be bad news. We've got some open surfaces, that's no big deal. Okay, to go a little bit further with a check on the geometry, flow simulation has its own check. You'll find that under flow simulation tools, check geometry. Again, I recommend you do this on every single project that you have in flow, okay, whether it be internal or external. If there's invalid contacts, they'll be reported down here below, and we don't want to go forward without resolving those. That's like a line contact, a point contact. Flow does not like that. For an internal project, we should have a non-zero fluid volume. If your volume is 0 here for fluid, that means we probably have an opening. You have lids to close off the openings, like this one here, and everything has to be closed off for an internal project. All right, so the next thing I recommend is that you do a tools interference detection. This is not absolutely required, but it's part of understanding your model before you try to run it. Okay, flow simulation is a lot more forgiving for interferences than, say, SOLIDWORKS simulation. Okay, but it still has to go through and calculate a Boolean solid calculation for the solid volume and fluid volume, and if these interferences affect that process negatively, it could play into your results. Okay, so we just want to know, are there interferences, yes or no? If there are, we'll keep those in the back of our mind if we get anything strange at the end. Okay, it may just simply mean we need to do mesh control in a certain area. All right, so the next thing I recommend is before you hit run, go to flow simulation, solve, run, uncheck the solver, just mesh it first time through. So if you do that, that will mesh it, but it won't run it. And then you can easily get a cell count under flow simulation, results, go to results summary, and it's going to give you a general idea of how large this project is. Okay, we've got in this one about 100,000 cells, 45,000 or so are fluid, about 9,000 solid cells, about 47 that are partial cells. Okay, in other words, they're fluid and solid. But we want to understand if you've got an inordinately large number here, let's say you end up with something similar to this geometry and you've got 1.6 million, then probably want to back up, apply some mesh control, simplify the model, get rid of unnecessary detail, come back in, mesh it again, okay, try to bring that number down to a reasonable number, which would be probably, if we could bring it down from 1.5 million to like 700,000, that's going to be a much more approachable problem. And keep in mind, you're probably not going to get a perfect run the first time. You may have to go in and change some parameters, do a rerun, right? So we want to save as much runtime as we can. So those 5 recommendations are what I recommend you do on an internal project every single time. And this is Tim Roberts at Go Engineer. Thanks for watching this video.